This is the quiz review, the third pre-calculus quiz in our identities unit on sum, difference, double, and half-angle identities. I'm going to do some of the classwork, warm-up classwork problems for you on the video and all of the homework. So for number 1A, 285, we have to think of as a sum or difference of some of our special angles. So because it ends in a 5, I'm going to take out 45. So if I do 285, can you see that? Minus 45, we get 240, and 240 has a reference angle that I know. So if I do 240 plus 45, I can use the sum identity for sine. So here we go. Here's my formula sheet. Here's the sine sum. So it's going to be sine, cosine, same, the plus and the plus. So this is sine, cosine, plus cosine, sine. And then I need the values for those, so I'm going to use my pictures up here. 240 is in this quadrant, 60 past 180, so sine of 60 is root 3 over 2, but negative in the third quadrant. Cosine of 45 is root 2 over 2. Cosine of 60, because it's the same reference angle, is 1/2. And sine of 45 is root 2 over 2. So this gives me negative root 6 over 4 plus root 2 over 4 that I can combine to negative root 6 plus root 2 divided by 4. And that is the final answer for 1A. Now I'll do a radians one. So B is cosine of 7 pi over 12. So in fractions, I actually find this a little bit easier because I know 12, to make that common denominator, had to be a third plus a fourth. And I'm going to have the pi's here. So to add them, like if I'm going to go backwards from the 7, the 3 would have needed times 4, and the 4 would have needed times 3. So see how 4 plus 3 is my 7 over 12? So this is pi over 3 plus pi over 4. So cosine, the identity, if I go to my cosine sum, and if I use that pattern, is cosine, cosine, change, sine, sine. And then cosine of pi over 3 is 1/2. Cosine of pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2. And sine of pi over 4 is root 2 over 2. So this is root 2 over 4 minus root 6 over 4. Oh, it's the same answer as A. Root 2 minus root 6 all over 4. Okay, so then for number 2, it says theta is in the fourth quadrant. So that's down here. And cosine is adjacent over hypotenuse. So using Pythagorean theorem, 12 squared plus y squared is 13 squared. You can use your calculator if you want. 13 squared minus 12 squared. So we get negative 5 is the down y value. So now A, well, I guess this is for all, the picture is for all 3 questions. So A, sine of 2 theta expands to 2 sine cosine. So 2 sine cosine. So from the picture, sine is negative 5 over 13, and cosine is 12 over 13. So this is like 2 over 1. 13 times 13 is 169. 2 times 5 times 12 is negative 120. So we could do the same thing for B and C. Let's do B. That's cosine of 2 theta. So you can pick, there's 3 choices for cosine. I'm just going to do the first one, which is cosine squared minus sine squared. So that gives me cosine from the picture squared and then sine from the picture. Cosine is 12/13 and sine is -5/13. So this is 144 over 169 minus 25 over 169. And then subtract. We get 119 over, oh, sorry, you can't see that, over 169. Oh, I don't know what you couldn't see. So 12 squared is 144, 13 squared is 169, -5 squared is 25, 13 squared is 169. The subtraction carries down, and then we simplified our answer. So C says tangent of 2 theta. Don't panic. If you look at your formula sheet, there is no tangent 2 theta. But I know that tangent is sine divided by cosine. And guess what? We already had the sine answer. And I already have the cosine answer. And when we divide with a complex fraction, that is the same thing as multiplying by the reciprocal of the denominator. And there's our answer, -120 over 119. Okay, so the rest of this page is similar. Number 3, it doesn't tell you the specific quadrant, but sine is positive and tangent is negative. So that would be this quadrant where that happens. You can label your picture opposite over adjacent and find the hypotenuse. These we have to use half angles, and here's half angles. All right, on to the homework. Solve. Sine 2x minus sine x. So I'm going to use the identity for sine 2x, which is 2 sine x cosine x. And then to finish solving this, they have a sign in common that I can factor out. And I can set each factor equal to 0. I'm going to isolate the cosine x here, add the 1 over, divide by 2. And now which angles give me sine is equal to 0? I'm doing degrees. I'm going to use this picture for the 0 and the -1. So sine is the y, that happens here, and I include 0 and not 360. And then over here at 180. And then when is cosine a half? I'm going to go back to my other special pictures. So cosine is adjacent over hypotenuse, so adjacent to the 1 is 60. But then I need the other positive quadrant for cosine with a reference angle of 60, which is 300, because that's this here, so this angle is 300. All right, number 2. Oh, we got sine of 2x again, so I'm going to replace that with its identity plus cosine of x this time. Now we share a cosine that I'm going to factor out. Set each factor equal to 0. I'm going to isolate the sine x, so I subtract 1 and divide by 2. So where is cosine 0 is the x coordinate is 0, which is at pi over 2 and 3 pi over 2. but the answer should be in degrees, so this is 90 degrees and 270. So used to radians. And then when is sine opposite over hypotenuse? Back to these pictures. So opposite of the 1 is 30, but it's a negative. So that puts your 30 degrees past 180. And your 30 degrees almost to 360. All right, number 3, cotangent in there. Ooh, wait, there isn't a number 3, it's just number 4. Okay, so it says sine of 2x minus cotangent of x. Sine of 2x, I'm going to use my identity again. And I'm going to make cotangent into cosine over sine, because nothing's going to factor. Then I think I'm going to make a common denominator. So this needs a sign in the denominator and another sign in the numerator. So as one big fraction, we've got 2 sine times sine is sine squared. And when we're solving, if I multiply both sides by sine, we really just get the numerator equal to 0. Now I can factor out a cosine. And then set each factor equal to 0. I'm going to isolate the sine squared, so that's going to give me, oops, sine squared x is positive 1/2, but then I'm going to square root both sides. I ran out of paper. So continuing that, when you square root both sides, we get plus or minus the square root of 1 over the square root of 2. All right, so solving, when is cosine 0? That goes all the way back here. Where is the x coordinate 0? We already answered that before. That is at 90 degrees and 270 degrees. But then sine being plus or minus 1 over root 2 is every reference angle of 45 degrees. Because it's positive or negative. So that's this quadrant with 45, this quadrant, and this quadrant, all with 45 to the x-axis. Okay, what's next? Use an identity to simplify and find the exact value. All right, so now we gotta match backwards. Let me do this. Sorry, there's too many papers here. 2 sine angle cosine angle matches to this. So that's sine of 2 times 112.5 degrees. So let's figure what is 2 times 112.5, 225. Sorry, there's a glare. So that is sine of 225. Well, 225 has a reference angle of 45 degrees in the third quadrant. So that's going to be negative 1 over root 2 or negative root 2 over 2, whatever answer you prefer. So now for number 2, we've got cosine squared minus sine squared. And I see that here in this identity. So that gives me cosine of 2 times 15. Ooh, that's 30. So cosine of 30 degrees. Go to these pictures. Cosine of 30 is root 3 over 2. All right, and number 3, 2 cosine squared minus 1. Oh, that's here again. So that's cosine of 2 times pi over 8, which is cosine of pi over 4, because 2 over 8 reduces to 1/4. And cosine of pi over 4 is 1 over root 2 positive, that's my equal sign, or root 2 over 2. So I just realized all this homework, none of them have half angles, so let me go back to the classwork for a minute and do a half angle problem for you. Well, I'll just do 5, I have room. So sine is negative and cosine is positive, happens in the 4th quadrant. And sine is opposite over hypotenuse. You're going to use Pythagorean theorem to find the missing side. And then I need my sine half angle. So sine of theta over 2 is this. So that's plus or minus 1 minus cosine of theta over 2. All right. So that's 1 minus cosine of this picture is adjacent over hypotenuse. Ugh. All right. To simplify that, let's use our calculator. So 1 minus 5/13 as a fraction is 8/13. But then I'm going to divide by 2 as a fraction, and I get 4/13. The plus or minus the square root of 4/13. Well, the square root of 4 is 2. And I'll leave the root 13 in the bottom. And then you can use this same picture and do the cosine of pi over 2. And then tangent, I'm sorry, not pi, theta. And then tangent would be sine divided by cosine.